Section 2.7 is talking about models and lots of application in this section. So let's get down to it and start with exercise number 10. Section 2.7, exercise number 10 is talking about price of ivory. According to the World Wildlife Fund, a group in the forefront of the fight against illegal ivory trade, the price of ivory in dollars per pound, or dollars per kilo, compiled from a variety of legal and black market sources, is approximated by the following functions. And as you can see, there are two pieces to these functions. One is defined over t between 0 and 8, and the other one over t from 8 to 30, where t is measured in years, with t equal to 0 corresponding to 1970. So basically the data they use is from 1970 to 2000 for 30 years. Sketch a graph of the function, and B, what was the price of ivory at the beginning of 1970, at the beginning of 1990? We did a similar problem to this, so it should not be that difficult. So let's write down the function. This is f of t, and by the way, f of t is the price of ivory per kilo. You realize that. This is price per kilo. That is equal to 8.37 t plus 7.44 if x is greater than or equal to 0 and less or equal to 8. And it would be 2.8 for t plus 51.68 if x is greater than 8 and less than or equal to 30. So first it wants you to sketch the graph of this function. So I'll do the t here, time, and here you would have f of t, which is the price of ivory. Here you would start with 0, let's say. T has to go all the way to 30, so let's say here is 5 years, here is 10, here is 15, here is 20, 25, 30, and on. For the first part, what we're going to do is, between x of 0 and 8, I use the first function. So what I'm going to do is, not x, t of it. What I'm going to do is a little t table here for the first one and put t here and f of t here. And when t is 0, in the first function, when t is 0, f of t would be equal to 7.44. So that's like the y-intercept. The other extreme, when t is equal to 8, so in place of t I put 8. 8 times 8.37, so 8.37 times 8, 66.96 plus 7.44, 0, 4, 4, 74.40. I'm gonna clean this. So I have 0 here, and let's say I have 50, 100, 150. For the first part between 0 and 8, you start from right here as the intercept at 7.44, and when it goes to 8, let's say 8 is here, this goes to 74.4. Let's say this is 74.4. And then let's take another extreme and see where you go to 30, what would happen. When you go to 30, then you're using this second function, so it would be 2.84 times 30. That is 85.2 plus 51.68, 6, and 136. Hopefully I did this correct. So when t is equal to 30, it would be 136.88. Let's say 136.88 would be here. So for 30, I'm going to clean this calculation from the middle. I don't need that. Something like this. So this is sketching the graph. So it means for the first 8 years, the price went up sharply and then slowed down a little bit for the next 22 years, actually. Part B, this was part A. This was part A. Part B says, what was the price of ivory at the beginning of 1970? The beginning of 1970 means that t is equal to 0. When t is equal to 0, we already calculated that. You use this function and price of ivory would be 7.44. So B, price equal 7.44 in 1970. How much was it in 1990? In 1990 is year 20. T would be equal to 20. So when t is equal to 20, you use the second function. So price, or actually what you're doing is you're evaluating the function, your function at 20. That would be equal to 2.84 times 20 plus 51.68. So it would be equal to 56.8 plus 51.68. The total of that would be 100. 107.48, I assume. This is in 1990. I'll take care of that problem. Another problem I want to do from this section, chapter 2.7, is problem number 16. Problem number 16, chip sales. It says, the worldwide flash memory chip sales in billions of dollars is projected to be S of t equal to 4.3 times t plus 2 to the 0.94 power for t between 0 and 6, where t is measured in years with t equal to 0 corresponding to 2002. Flash chips are used in cell phones, digital cameras, and other products. What were the worldwide flash memory chip sales in 2002? What are the projected sales for 2008? Okay. So here, problem number 16, you have a projected sales using this function S of t, 4.3 times t plus 2 to the 0.94. T of 0, this is defined for t between 0 and 6. So at the beginning in 2002, that means t is equal to 0. In 2002, t is equal to 0. So S of 0 equal to 4.3 times 0 plus 2 to the 0.94. So that is equal to 4.3 times 2 to the 0.94, which is equal to approximately 8.25 billion dollars. S of 0. This is sales in 2002. In 2008, that is 6 years later, in 2008, t would be equal to 6. So in the same function, I find S of 6, which is equal to 4.3 times 6 plus 2 to the 0.94. Therefore, S of 6 is equal to 4.3 to the 8 times 8 to the 0.94. And if you use your calculator, here you would get approximately 30.37 billion dollars. This is sales or projected in 2008. Want to do one more problem from section 2.7, chapter 2, section 2.7, and that is problem number 34. Problem number 34. Profit of a vineyard. Philip, the proprietor of a vineyard, estimates that if 10,000 bottles of wine were produced this season, the profit would be $5 per bottle. But if more than 10,000 bottles were produced, then the profit per bottle would drop by 0.0002 for each additional bottle sold. Assume at least 10,000 bottles of wine are produced and sold, and let X denote the number of bottles produced and sold above 10,000. Above 10,000, that's very important. Your variable is always very important to understand, what is you're trying to solve for. So here, X is the number of bottles produced and sold above 10,000. So if X end up being like 2,000, you're talking about 10,000 plus 2,000, 12,000 for the number of bottles. Find the function P that gives the profit in terms of X, and B, what is the profit Philip can expect from the sale of 16,000 bottles from the Vineyard. Again, section 2.7, number 34. The profit, shown as P of X, would be equal to 10,000 plus X, which is the number of bottles sold above, multiplied by the price, which is $5, minus, now this price goes down for every unit above 10,000. So it would be 5 minus 0.0002 times X. So for example, you can see if $5 was not the price, $5 was the profit per bottle. Yeah, $5 is the profit per bottle, my mistake. So you can see here if X, for example, is equal to 0. Let me just explain this to you. If X is equal to 0, that means you're not selling anything above 10,000, then your profit would be equal to 10,000 times $5, because it's $5 per bottle you make. That is equal to $50,000 if X is equal to 0. Every time X goes up, for every unit of X going up, profit is going to go down by this much. So what we have to do here is to simplify that profit function, which would be equal to, I'm working from here. This was just an example. This was just an example to understand the problem a little bit better. So this would be equal to 10,000 times 5 is 50,000 minus 0.0002 X times 10,000 would be equal to 2X. X times 5 is plus 5X. And X times that would be equal to minus 0.0002X squared. Therefore, profit is equal to, let me write the one with the highest power first, minus 0.0002X squared. Here I have minus 2X and plus 5X. That would give me plus 3X plus 50,000. This is my profit function. This is my profit function. for any value of X, all I have to do is to plug in whatever value I want for X, and I can figure out how much profit it would be making. So in part B of this problem, it says, what is the profit Philip can expect for the sale of 16,000 bottles of wine? So this is basically part A we just did. In part B, it says sale of 16,000 bottles. Well, when you're selling 16,000 bottles, X is equal to, remember we define X as the number of bottles above 10,000. So X would be, in this case, equal to 6,000. That's very important, not to put the whole 16,000 in the equation right here, in the profit equation. X is actually 6,000 because X is the number of bottles over 10,000. So your profit function, you put for X, for this X here, for this X, you put 6,000. Every place you have X. There is X here, there is X here. So we get P of 6,000 equal to minus 0.0002 6,000 squared plus 3 times 6,000 plus 50,000. If you go ahead and use your calculator and calculate the profit here, it would end up being $60,800. So that is, if the sale is 16,000 units, the profit would be 60,800 units.